Hello, we are at learn.detroitbonesetter.com. We are going to go over the answers of rotational assessment with mbcase 1. So here's the CT rotational profile of the bilateral lower extremities, the right side on the right, right side on this side, left side over here. These are CTs. You try to scroll to get an image where you can see the femoral neck and draw a line down its axis. So we're going to start with the right side, draw a line of best fit down the axis of the femoral neck, and then a reference line flat to the floor. Another angle along the posterior femoral condyles, and a line flat to the floor. And similarly for the ankle, a line of best fit through the syndesmosis and a line parallel to the floor. Now I have described doing it perpendicular to the incisura, or you can do a line of best fit, and then you obviously want to adjust them to make them accurate, and really do your interpretation yourself and practice. You can do these on 2 different occasions to see how reliable you are at each set. Okay, so we're going to start with the right side. We're going to look at the femoral neck, distal femur, and ankle. And then, of course, what you're getting paid for is the net, is interpreting how to do the math between the femoral neck and the distal femur. So for the femoral neck in blue, we're going to round it 3 degrees, externally rotated. On that static image, that's externally rotated 3 degrees. The distal femur is in green, that's 24 degrees, and that's internally rotated. At the ankle, in yellow, it's 20 degrees, externally rotated. So the net, the femoral version, okay, for this patient, the way I think of it is I have to rotate the femurs so that the femoral condyles are flat to the floor. So I'd have to externally rotate this 24 degrees to make the femoral condyle flat. As I externally rotate this 24 degrees, this will increase its external rotation. It's already at 3 degrees externally rotated, so it's going to increase its external rotation. So this would be 24 plus 3, or 27 degrees. And because when these femoral condyles are flat, the femoral neck would be pointed externally rotated or this way. And that is called antitorsion. So 27 degrees of antitorsion, antiversion. Okay, there is a difference between the two. I'll just write both down in case you have heard the antiversion, not the antitorsion. For the tibia, again, we're going to have to externally rotate this to make them flat, 24 degrees. This is already externally rotated, so it's going to be 24 plus 20, so it's going to be 44 degrees of external tibial torsion. Okay, and then I'll just copy these just so I don't have to write as much, and we'll do the left side. Left side. Okay, so left side now. A line of best fit down the femoral neck, parallel to the floor. Another line along the posterior femoral condyles, parallel to the floor. Just adjust that. Another angle through the ankle joint. And there you go. Okay. So for the femoral neck, we have in turquoise, we have 2 degrees of external rotation. Distal femur in purple is 23 degrees of internal rotation at the ankle. In orange, 22 degrees. So the femoral version for this patient, again, we're going to have to externally rotate this by purple, 23 degrees to make them flat. This is already at 2 degrees externally rotated, so it's going to be 2 plus 23, so it's going to be 25 degrees of antitorsion. Again, as the femoral condyles are flat, this femoral neck will increase its external rotation so that the femoral neck will be pointing this way, and that is called antetorsion. For the ankle, we're going to take, again, the purple, we're going to externally rotate it 23 degrees. This is already externally rotated 22, so it's going to be 23 degrees, 23 plus 22. So it's going to be 55. I need my calculator. 22 plus 23 is 45. Apologize, it's embarrassing. 45 degrees of external tibial torsion. So you can see here the patient has 27 degrees of antetorsion or anteversion on the right side, 25 on the left. Those are symmetric. Patient has 44 degrees of external tibial torsion on the right and 45 on the left. So pretty symmetric patient, and that's how that's one method of obtaining rotational assessment using axial CT scans.